Earlier this week, we talked about cross sections of 3D shapes that were prisms and pyramids. When we found these cross sections, we realized that all of them had straight edges, and there were things like rectangles, squares, triangles, and trapezoids. Today we're going to look at some shapes that are curved, and that's going to change the way that we talk about cross sections. So our first three shapes are listed here. It says to name each figure, shade the bases of them, and if a figure has no base, to explain why. So our first shape is a sphere. It clearly has no flat spots, just like a basketball. So if it has no flat spots, it cannot have a base, and so a sphere has 0 bases. A cone has 1 circular base, and a cylinder has 2 circular bases. First set of practice questions here ask us what type of three-dimensional figure an orange is, and an orange is a sphere. And then it asks us if we were to slice that orange to reveal a circular cross-section, how could that orange have been sliced? And the answer to that is anywhere. Now, they could create different size circles when you slice it, depending on where you slice, but no matter where you slice a sphere, you are going to get a circular cross-section. So number 6, will all the cross-sections of the orange be identical? We kind of just answered that one. All of the slices can be different depending on where you decide to slice that orange. They will, however, all be circular. All right, then we come down here to our cylinder. Marianne is cutting a cucumber. She cuts the edges off of that cucumber, and she ends up with a cylinder that you can see in the picture. When she slices the cucumber again, parallel to the base, what is the shape of the cross-section? So this part is really important that you understand the bases here are circles. And so we have to pretend that this cucumber is kind of standing up on its end if we want to visualize cutting it at parallel to its base. So if I were to make that first cut parallel to the base, I would end up looking at a cross-section that is a circle. Next, Marianne cuts the cucumber in half by making a slice that's perpendicular to the base. And so that's going to hit the base at a 90-degree angle. And if I were to open up that cucumber at cut number 2, I would be looking at a rectangle. Then it takes it one step further when Marianne slices one of the pieces from problem 9. This time the slice is parallel to the bases. What is the shape of the cross-section that's revealed? In this case, it would end up being a half circle because she's already cut it at the at cut 2. And then she would take it and slice it at cut 1, and you would be looking at this half circle. All right, your next set of examples is about the cone, and in this case they use a real life example of a carrot, which is shaped much like a cone. The carrot is going to have a base that is a circle, and it's going to have one of those circular bases. And then when it comes to a point, we're going to call that the vertex. And so when we refer to the vertex of the cone, we're talking about the tip of the carrot there. All right, so number 1 says, how can you slice the carrot to create a cross-section that is a triangle? Perpendicular to the base through the vertex. So what that means is I'm going to go straight down through the point to the circular base and hit it at a 90-degree angle. If I opened it up, that would create a triangle. How can you slice the carrot to create pieces that's shaped like half ovals? This one was a little hard for me at first, but if I take it and I cut it diagonal through the base, I would end up with some half oval shapes. How can you slice the carrot to create pieces that are ovals? And that would just be diagonal through the curved side of the cone without going through the base. So an example of that would be this line here. So parallel and perpendicular were part of your vocabulary for this topic, and they are very important words. So if you understand what they mean, it makes it a lot easier for you to visualize what your cross sections would look like. So this says to label each line as parallel or perpendicular to the base of the cone, and I went ahead and did that. Remember, perpendicular is going to meet the base at a 90-degree angle, go straight down. Whereas parallel is going to run side by side with the base and never intersect. Number 4 asks us to describe the relationship between the cone and the line that's given. I would like to say that's just a diagonal line, but they wanted us to use some other words. So I said the line is neither parallel or perpendicular to the base or the vertex. Number 5 wants us to draw a line that's parallel and perpendicular and label them. So I went ahead and did that in different colors so you could clearly see it. And number 6, how are the cylinders, cones, and spheres similar, and how are they different? This is kind of what we talked about at the beginning of the lesson. They all have curved edges, but spheres are weird because they have no base, cones have 1 base, and cylinders have 2.